Hello, guys. Welcome to Romta Solutions and welcome to your last lesson on grade 12 probability. So, today we are looking at different probability problems that you will come across in your grade 12 examinations. Of course, this will help you in all your exams that you will come across, whether you're writing in June, September, or November. Okay? So, without any waste of time, let's get into it. So, the first question, or rather the first example, says, three married couples, Mr. and Mrs. Small, Mr. and Mrs. Beaver, and Mr. and Mrs. Koza, are to be seated on a bench. How many ways can the people be arranged? Let me see if it works if I use a blue color. Okay, it's perfect. Yellow? Yeah, not nice. Let me use blue. All right. So we have three couples. If it's three couples, that means we have six people. So the first question did not dictate as to how they should be seated. We are just letting them sit. It doesn't matter who's sitting next to their spouse. So we have six people, and since it doesn't matter who's sitting next to their spouse, we have six factorials. Okay? We have six factorial ways of arranging these couples, which is 720 ways of arranging them. So it doesn't matter who's who, they can sit however they like. Even if Mr. and Mrs. Small don't sit next to each other, it's okay. The other partner shouldn't complain. Okay, now number B, or question B, calculate the probability that Mr. and Mrs. Koza are seated next to each other on the bench. Pay attention, this question only wants you to arrange Mr. and Mrs. Koza. How do you arrange them? Mr. could sit on the left, or Mrs. could sit on the left. Mr. could sit on the right, or Mrs. could sit on the right. So there are two ways in which they can sit. So we have, for this question, we have two factorial ways of seating the couples. And while you are on it, this couple, there will be a unit. So we are left with Mr. Small. We are left with Mr. Small, Mrs. Small, Mr. Beaver, Mrs. Beaver, and the couple. All right. So this seat can take six people. All right. Now we have arranged our couple. We can arrange them in two ways. But to arrange the rest of the group, considering our couple can sit anywhere, but wherever they sit, Mr. and Mrs. Koza must sit next to each other. So we have 1, 2, 3, 4, 5 factorial ways of arranging our couple. Arranging these people, having taken the couple as a unit. So our answer, it's not really our answer, but because the question is looking for factorials of probability that Mr. and Mrs. Koza are seated next to each other, we will say a reminder, probability of an event, let's say event A, is basically number of outcomes of event A over sample space. So this 6 factorial is our sample space, and our outcome, the event that we are interested in, is Mr. and Mrs. Koza sitting next to each other. It's this way. So this we have 2 factorial multiplied by 5 factorial all over 6 factorial. Now what is our answer? Our answer is simply 2 factorial multiplied by 5 factorial all over 6 factorial. So our answer is simply 1 over 3. So we have 1 over the probability that Mr. and Mrs. Koza will sit next to each other is 1 over 3. Okay. I hope you guys understand this. All right. Now, moving on to the next example. So the word curriculum, letters of the word curriculum are arranged to form other words. Assume that all the words have a meaning. Okay, that's okay. Now, how many different words are possible? This question, when you look at it, how many different words are possible? The word curriculum, let me see, it's made of how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 10. It's made of 10 curriculums. It's made of 10 letters, and I see some letters repeating. How many letters are repeating? C, U, R. Okay, only 3. So let's see. C repeats twice. U repeats 3 times. And R repeats twice. Okay. This is 7. All right, perfect. Now, when it's like this, you recall a formula when letters are repeated. N equals M sub 1 factorial multiplied by M sub 2 factorial multiplied by M sub 3 factorial. Do you remember that? Okay. So we have how many letters are making curriculum? 10 letters are making the word curriculum. C repeats twice. U repeats 3 times. R repeats twice. So how many words are here? Let's see. C. 10 factorial over 2 factorial times 3 factorial times 2 factorial. Do we have? We have 151,200 weights. So we can make 151,200 weights from the word curriculum. Okay? From the word curriculum, we can make this number of weights. Number B, or question B says, what is the probability that a word starts and ends with the letter U? So if this is U, and then 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It ends with another U. So if you recall, U had curriculum had U repeating 3 times. All right. So what is happening is this. For this word, you will recall, you take, for curriculum, there are 3 words that are representing the word, there are 3 U's. You take one of the 3, right? And when you take one of the 3, you are left with 2 of the 3 U's. You take another U, right? So in other words, for this, you have 2 U's. So you are only left with 1 U here, okay? Now, the probability that you start with a U and then end with a U would be, let's see, you have 3, right? You have 3 times this 2 times, be careful. Here, how many letters do you have? You have 8 letters. You now have 8 letters that you have to arrange. Out of the 8, okay, pay attention, of the 8, there are those that are repeating. C is repeating twice and R is repeating twice. All over 151,200. Okay? All over 151,200. Okay? So let's see what we're getting. 3 times 2 times 8 factorial over 2 factorial times 2 factorial all over 151,200. What do we get? Here we get 2 over 5. Okay? So the probability that a word starts and ends with the letter U is 2 over 5. Okay? It's 2 over 5. All right. Perfect. Remember, guys, if you have questions, do send us a WhatsApp text, email us, or alternatively on YouTube, you can comment and we will work things together. Okay, moving on. Number 3, a teacher has 5 different poetry books, 4 different dramas, and 3 different novels. She must arrange these 12 books from left to right on a shelf. Number A, we have 12 books, of course. Write down the probability that a novel will be the first book placed on the shelf. 1, 2, 3, 4, 5, and so on. Right? And so on. So this is a novel. For a novel, we have 3 novels to choose from. So this is 3. All right? Now, if you take one of the 3 novels, you are left with 2 here. Okay? However, since you're left with 2, that means you've taken one of the books, you are now left with 11 other books. So this will be 11 for this here, 10, 9, 8, and so on. So when you look at it, the question is saying, determine the probability that a novel will be the first book placed on the shelf. So, probability that you will have a novel first, all right, that you will have a novel first will be 3 times. When you look at this, it'll be 11 factorial, okay, because it's 11, 10, 9, 8, blah, blah, till 1. So it's 11 factorial over 12 factorial, right? So this is basically equal to 3 over 12. Your calculator will return 1 over 4. Okay? Your calculator will return 1 over 12. Be careful. I did not say 3 factorial. I said 3 because there are only 3 options to choose from. Okay? 3 options to choose from. I'm only taking one of the 3. Okay? I'm only taking one of the 3. Okay? Perfect. Now, they say calculate the number of different ways. Number B, calculate the number of different ways these books can be placed on the shelf if any book can be placed in any position. So here, it can be novels, it can be drama, it can be poetry. It doesn't matter. They didn't tell us. Oh boy. They didn't tell us which one to start with. They say any. So we're not going to waste our time. For question B, we will say this is 12 factorial ways. Now, what is 12 factorial? 12 factorial is 479 million and 1,600. All right, so 479 million 1,600 ways, right? 1,600 ways that you can place these books on a shelf. Number C, calculate the probability that a poetry book is placed in the first position. So this one, I have to be careful. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They say poetry in the first position. And then the 3 novels are placed next to each other. Oh, so I'm hearing the 3 novels next to each other. So it'll be 3 factorial. It'll be 3 factorial for the 3 novels, okay? 3 factorial for the 3 novels. And then how many poetry books do we have? We have 5 poetry books. We have 5 poetry books to choose from. What else did they say? Oh, where am I? Okay. Now, the 3 novels are placed next to each other and a drama is placed in the last position. Drama in the last position. How many drama books are there? There are 4 drama books. So we choose one of the 5 poetry books and we choose one of the 4 drama books. So in total, there are, 12 books. So you have taken 1 for poetry, 1 for drama. How many books do you have left? You are left with 10, right? You are left with 10. But then you also minus 3 books, which is novels. How many books do you have left? 7, right? So you have to, wherever you place your books, the novels must be next to each other. So without the novels, you have 7 books. But now, these novels, we consider them a unit. So this will become 8, right? This will become 8. So here, we have 8 factorial ways of placing these objects. Okay, here we have 8 factorial ways of placing these objects. Okay, we have 8 factorial ways of placing these objects. I repeat, when you have taken one poetry book, one drama book, you will have 10 books to deal with. However, the novels must be placed next to each other. So when we remove them, we have 7 books. So because they have to be placed next to each other, we'll consider them a unit. Thus, instead of it being 7, it will now be 8. Okay? Therefore, probability that you start with poetry and then end with drama and that your novels are next to each other is 5 times 4 times 3 factorial times 8 factorial all over. These books without any order will be 12 factorial. All right, so take your calculator. This is 5 times 4 times 3 factorial times 8 factorial all over 12 factorial. Okay, all over 12 factorial. So our answer is 1 over 99. Our answer is 1 over 99. Guys, in your exam, please do not be afraid to show your steps. Wherever you're working, don't be afraid to show it. Just show it. Okay? Just show it. So this is it, guys. Now your answer is 1 over 99. Perfect. Now, let's see. 2 learners from each grade at a high school, that is grade 8, 9, 10, 11, 12, are elected to form a sports committee. In how many ways can the members be arranged in a straight line if the chairperson and the deputy chairperson of the sports committee be elected if there is no restriction on who may be elected? So for this one, it's easy. They are taking 2 individuals from a grade, and there are 5 grades at this high school. So that means there is a total of 10. So you have 10 for the first place. Whether you start with the chairperson or deputy chairperson, it doesn't matter. And then when you have chosen one of the 10, you have 9 for the other position. So in other words, you have 90 ways. Okay? You have you have 90 ways of choosing your chairperson and the deputy chairperson. Okay? Perfect. Now, a photographer wants to take a photograph of this sports committee. Now, how many ways can the members be arranged in a straight line if any member may sit in any position? Now, there are 10 people. Anyone can sit wherever they like. And that means you have 10 factorial ways. So what is 10 factorial? 10 factorial is 3,628,800 ways. Okay? Remember, it's 10 factorial ways because there is no order. Anyone can sit wherever they like. Moving on. Now, how many ways can they be arranged if members from the same grade must stand next to each other and the grade 12 members must be in the center? So I will say basically we have 5 grades. 1, 2, 3. Let me change the color. 1, 2, 3, 4, 5. However, the grade 12s must be in the center. Okay? The grade 12s must be in the center. Okay? So what is happening now? They have said members from the same grade must sit next to each other. So to arrange them, we have 2 factorial ways because there are 2 members from each grade. So this is 2 from grade 8, 2 from grade 9, 2 from grade 10, 2 from grade 11, 2 from grade 12. Remember, even grade 12, we can arrange it, right? We can arrange it because one of the 2, let's say it's a boy and a girl, one can sit on the right and the other on the left. Multiplied by, because now we are taking all these as a group, right? As a unit, we have how many units to choose from? Excluding the grade 12s which are in the center, we have 4 groups to choose from. In other words, that means we have 4 factorial ways. Okay, that means we have 4 factorial ways to place grade 8, 9, 10, and 11 in between these 4 places. Okay, all right. Now our answer is, let me see, this is 2 times 2 times 2 times 2, so 2 to the 5. This is 32 times 4 factorial is 24. Okay. So our answer is 768 ways in which members from the same grade can stand next to each other and the grade 12 members are in the center. So this is 768 ways. Okay, this is 768 ways. Right, happy? Perfect. All right, moving on. Now, example 5 is interesting. With this one, guys, you need to be careful. All right, in a certain province, that should have been a comma, vehicle number plate codes have the following format: at, hash, 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 which is 3 letters followed by 3 digits, where at represents a letter of the alphabet and hash represents a digit from 0 to 9. For each number plate code that is assigned to a vehicle, the following conditions must be met. All letters except E and G can be used and no letter can be repeated. So we have 1, 2, 3, 4, 5, 6. So what we know about letters, we have 26 letters. Let me use a different color. We have 26 letters, right? They say you must exclude E, G, and O. This means you have now 23 letters to choose from. Now, a condition is that no letter can be repeated, meaning there's no repeat. And then no number plate code can start with a vowel. So if your vowels, when we talk of vowels, we're talking of A, E, O, A, E, I, O, U. Okay? So we're talking of these. As you can see, this includes E and O. So how many letters do we have for the first place? No vowels and no E, G, and O. So that basically means for the first place you have 20, right? You have 20 because vowels include E and O, right? So E and O is included, and then you also subtracting the G. So basically 1, 2, 3, 4, 5, 6. So you are not considering the 6 alphabets. So for the first letter, you have 20. All right? Okay. All digits can be repeated and each digit can be, all digits can be used and each digit can be repeated. So this means you have 10, 10, 10. Right? Because you can repeat them. All right. So this is the situation so far. Okay, this is the situation so far. Now, they said no number plate can start with a vowel. So, now that here you have taken one of the consonants, and remember, here no vowel can be used, but in these 2 places a vowel can be used. So if you have taken a consonant, and basically you have 23 letters to choose from, excluding, you have 23 letters to choose from. When, you have 23 letters, because this one and this one, you don't consider it at all, right? Now, you have 23. Now, if you have taken one of the letters of the 23, right, you have taken one of the letters here of the 20, which means you have taken one of the letters of the 23, right? So if that's the case, this means you are left with 22 for this place, because now vowels can be included. And then here you are left with 21 because no letter can be repeated. I repeat, for this place, no vowels can be included. Hence, there are 5 vowels, and of course, G is not used at all. So it's 20 to choose from. Right? It's all the consonants except G to choose from. Right? Now, if you are only including E, G, and O, you have 23 letters to choose from. Right? Now, for the second letter, you can choose any letter except E, G, and O. Meaning now you can now use your other vowels, your A, I, and U. You can now use them. Right? You can now use them. But because I said, basically you have 23, but you have taken one of the 23 here. Therefore, this means you are left with 22 for this place and 21 for this place. Remember, no letter can be repeated. Okay, so number A is 20 times 22 times 21 times 10 times 10 times 10. What is our answer? Let's see. 20 times 22 times 21 times 1,000. So we have 9,240,000 codes or number plate codes. Okay, we have 9,240,000 codes. Okay, perfect. Now, B says, calculate the probability that a number plate code chosen from the number plate in question A at random contains only one vowel and ends with an even number. Okay. So what we know, I will do 2 places. 1, 2, 3, 4, sorry, 2 codes. 6 and 1, 2, 3, 4, 5, 6. So we know for this place we have 20 to choose from. And here, let me just say vowel. So it's I, it's A, I, U. So our vowels will be on the second place. And then for here, it'll be on the third place. Okay? So how many vowels do we have? We have 3 vowels to choose from. Okay? And of course, the numbers 10, 10, 10. Where are they? 10, 10, 10. Remember what we have said. For the first place, no vowel. Okay? Now, you need to be careful. Okay? You need to be careful. They say, oh, it ends with an even digit. It ends with an even digit. So, let me take it a bit down. I have to take it a bit down. Just the last place only, okay, guys? Let me take it a bit down. The last place contains 0, 2, 4, 6, 8. Okay? 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. Right? So they said it must end with an even digit. So to end with an even digit, for you to say you have an even digit, you can divide that number by 2. Any number that ends with 0, you can divide it by 2. That ends with 4, that ends with 2, that ends with 6, that ends with 8. You can divide it by 2. That number is even. Right? Perfect. So for this, we have 5 digits. Even here, we have 5 digits. So here, it's 10. So let's go back. Now, they said, calculate the probability that a number plate chosen from the number plates in question A at random contains only, underline only, one vowel. Okay? Contains only one vowel. So, this means, pay attention. Remember, when you did not consider vowels at all, you had 20 consonants to choose from. All right? You had 20 consonants to choose from. Now, when you include the vowels, you had 23. And now, because the first place didn't include the vowels, it was 20, and that reduced your letters to 23 for the second letter. Now, for this 23, there are they include 3 consonants. So if you take one of them, or you have 3 of them, you have 3 of them. So if you have 3 of them, and this 22, you can only take one. So that would basically reduce your numbers to 21 like we had here. But we don't need another vowel, right? We don't need another vowel. So since we don't need another vowel, we said we can be left with 21. But we don't need another vowel. That in this number, we have 2 vowels left. So you have to remove them. So what do you have? You have 19 consonants. Okay? You will have 19 letters. Right? You will have 19 letters. Now, let's answer the question. The probability that a number plate chosen from the at random contains only one vowel would be, probability would be, it's up to you. You can write this 20 times 3 times 19 times 10 times 10 times 5. It's this one here. Plus this one here. 20 times 19 times 3 times 10 times 10 times 5. All over, you recall, the sample space was 92400. So 9,240,000 codes. Take your calculator and see what you have. Let's see. On my calculator, I will say 2 times 20 times 3 times 19 times 100 times 5, all over 9,240,000. Okay, so what do we get? We get 19 over 154. Okay, so you asking yourself, why did I use 2 places? Remember, what this question is saying to us, it says it can contain only one vowel. That vowel could be on the second place or could be on the third place. So I have considered both places, second place and third place. Okay? All right. And I hope you understand now. All right. Remember, if you have any questions, you can WhatsApp us on this number here, email us, or you can comment below. Okay. Moving on. Let's see now. Now, looking at example number 6, it says the digits 1 to 7 are used to create a 4-digit code to enter a locked room. Are used to create a 4-digit code to enter a locked room. How many codes are possible if the digits may not be repeated? Remember, may not be repeated, and the code must be an even number bigger than 5,000. Okay, so numbers that may make this code to be greater than 5,000 are 5, 6, 7 to begin with. The first number could be 5, 6, or 7, right? But we need to play around with this so we don't mess it up. Okay, we need to play around with this so we don't mess it up. So let's maybe start with, I want us to start say this code starts with 5 or 6. Okay, so we have 1, 2, 3, 4. Okay, so it'll be 5 or 6. Sorry, 5 or 7, not 6. 5 or 7, not 6. Bear with me. 5 or 7, it'll be 5 or 7. So to be an even number, the last digit of that number must end with 0, 2, 4, 6, 8. So we don't have 0 here, we don't have 8, it must be 2, 4, 6. So for the first digit, we have 2 numbers to choose from. For the last, we have 3 numbers to choose from. Digits may not be repeated. Since they may not be repeated, we take 1 for the first and 1 for the last. That means we are left with 5 for this one here and 4 for this one here. Okay, so when your number starts with 5 or 4, how many codes are possible? 2 times 5 times 4 times 3, 10, 40, 120. So when when your code starts with 5 or 7, you have 120 codes that you can make. Now, what if it starts with 6? Remember, the temptation here was if you say 5, 6, 7, it will not end with a 6, it will end with a 2 or 4. When you recall, numbers may not be repeated. And all of these numbers, 5 and 6, they must have a code that ends with 6 as well. Hence, I've taken 5 and 6 instead of 5, 6, 7. So now for a code that starts with 6, we have 1, 2, 3, 4. So it starts with 6. It can only end with 2 or 4. Why? Because digits may not be repeated. So this is 1 and this is 2. When you've taken 1 and 1 here, you are left with 5 and 4. The 4, you have 1 times 5 times 4 times 2, 20, 40. So you can only have 40 codes, right? So total codes that you can make is 120 plus 40, which is 160 codes. All right, which is 160 codes. You can only make 160 codes with these numbers when you want a code that's bigger than 5,000 and an even number. Okay, perfect. Now number 7, given the digits 3, 4, 5, 6, 7, 8, 9. How many are they? 7. Calculate how many unique 5-digit codes can be formed using the digits above if, in figure 1, the digits may be repeated. If the digits may be repeated, you're making a 5-digit code. This is 7 times 7 times 7 times 7 times 7. All right? What is this? This is 7 to the 5, which is, let's see, 7 to the 5 is 16,807 codes that you can make if the digits may be repeated. Roman figure 2, they say digits may not be repeated. So with this one, remember that formula, n factorial over n minus r1. What is this? This was, you need to make 5. So this was 7 factorial over what? Over 7 minus 5 factorial, which is 7 factorial over 2 factorial. All right? So take your calculator, 7 factorial over 2 factorial. What do you get? you get 2,520 codes. Or you can say you have 1, 2, 3, 4, 5, 7, 6, 5, 4, 3, which is 7 times 6 times 4 times 3, or 7, 6, 5. 7 times 6 times 5 times 4 times 3. It will also give you 2,520 codes. It will also give you 2,520 codes. Okay? It will give you that. All right. So, are you guys happy? All right. So, you have two ways of doing this, all right? This is because the out, it's because you're choosing 5. Okay, perfect. Now, number B, how many unique 3 digits code can be found using the above digits if digits may not be repeated? Let me change the color. May not be repeated, greater than 4,000 but less than 6,000, and divisible by 5. Let's look at it. So for this one here, 1, 2, 3. Divisible by 5, that number, its last number must end with 0 or 5. We don't have 0 here, we only have 5, so it's okay. Now, if you start with a 6, as you can see, your number will be greater than 6,000. So you're not going to consider that. You can only start with 4. So it's 1 and 1. And since we said digits may not be repeated, that means you are left with what? 1y. So you're left with 5. So 1 times 5 times 1. This is 5 codes. This is 5 codes that you can make. These are 5 codes that you can make when your digits may not be repeated. So let me make it interesting. I'm going to change the color. So what if digits may repeat? So what if digits may be repeated? Oh boy, what if digits may be repeated? So if digits may be repeated, what are we looking at? So if digits may be repeated and the conditions are remaining except this one here, the code is greater than 4,000 but less than 6,000. Also, the code is divisible by 5. Obviously, what we have is it must end with 5, but it can start with 4 or 5, right? And we said the digits may be repeated. So this means you have, sorry, it's not 1, it's 2 here. And here, if digits may be repeated, you will have 7 of them here. So how many codes can you make? 2 times 7 times 1, which is 14 codes if the digits can be repeated or may be repeated. Okay? Perfect. Moving on. Now they say determine the probability of getting a cell phone number if the first digit is even. Okay. All right. I think I like this one. If the first digit is even. Yeah, I like it. If the first digit is even. And what do we say? The first digit is even. And none of the first 3 digits must be 0. So it's okay. So since, let me begin with 10. I will say 1, 2. I will just take 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? I think it's okay. All right. So let's see. So what am I looking at? So the first digit is even. For the digit to be even, that we are considering, for digits, we're considering 0 to 9. Right? We are considering 0 to 9. Right? We are considering 0 to 9. So what I'm looking at here, it's interesting. What I'm looking at here is this. Okay. Now, let's start. First number is even. For the first number to be even, it needs to start with 2, 4, 6, 8. Right? And highlight this. None of the digits may be repeated. Okay? For it to be even, it needs to start with 2, 4, 6, or 8. So that's 4 options. And then none of the first 3 must be 0. If none of the first 3 must be 0, you have taken one number here. How many numbers do you have left? You are left with 9, right? But because you don't have to take a 0, you are left with 8. And then again, you don't have to take a 0, you are left with 7, right? You are left with 7. Do you guys agree with me? You are left with 7. Now, another thing that you need to look at, collectively here, you are tempted to say you are left with 6 numbers because you saw 7. That is not true. There is no 0 that's supposed to be here, right? So it's okay. This is 4, 8, and 7. Now, here, you can now say it's 7, 6, 5, 4, 3, 2, 1. Can you see that? Now, the probability of getting a 10-digit code is, let's see, it's 4 times 8 times 7 times. I'm sorry, I'm not going to be writing all this. Agree with me that this looks like 7 factorial. Right? All over, how many places do we have here? We have 10. So all over 10 factorial. Okay? All over 10 factorial. All right? Perfect. Now, let's find our answer. What is it? Four times 8 times 7 factorial over 10 factorial. What is our answer? Our answer is simply 14 over 45. Interesting, eh? Very interesting. Remember, there are no zeros here. The first condition was that the first digit is even. For it to be even, it must start with 2, 6, 8. Okay, it must start with 2, 6, 8, not 0. Okay, if it was ending with, if it was saying it must end with an even number, you are going to consider 0. But because it's for a start, you're not going to consider 0. Okay, perfect. Now, let's see. So this is it. We sorted, right? All right. Oh, let's go to example 9. Of course, there is example 9. Okay, there is example 9. So they say a password. Let me see if I have. Okay, I have an extra page for this. A password is formed using 3 letters of the alphabet. So let me just say letter, excluding A, R, A, E, O, O, and using 3 digits, digit, excluding 0. So exclusions, L, it excludes vowels, digits excludes 0. Okay, digits excludes 0. Okay, so that means, okay, let's see, the numbers and letters can be repeated. Oh, okay, if they can be repeated, what do we have? We have, let's see, A, E, okay, A, E, I, O, and U. Okay, so this means you have 21, 21, 21, 9, 9, 9. Okay, that's fine. Now let's see. Now calculate the probability that a password chosen at random starts with the letter B and ends with the number 4. It's okay. Number A, 1, 2, 3, 4. They may be repeated. So here you start with 5, 6. You start with B, that's 1, and you end with digit 4. That's digit 4, that's 1. But you may repeat letters and alphabets. So that's 21, 21, 9, 9. So what do we have? 21, 1 times 21 times 21 times 9 times 9 times 1. What is it? Let's see. So this is 21 squared multiplied by 81. What do we have? 21 squared multiplied by 81. All right, multiplied by 81. So this is 35,721. Okay, since I will be wasting time, let me not just get this. Let me just say probability, therefore, of starting with a B and ending with a 4 is 1 times 21 times 21 times 9 times 9 times 1 all over. What is our total size? Our sample size will be this one here. What is it? 21 times 21 times 21 times 9 times 9 times 9. Okay. Yeah, that's better. Ooh, can't. Over 21 cubed multiplied by 9 cubed. Now our answer is simply 1 over 189. Okay. The probability that a password will start with letter B and ends with the number and end with number 4 is 1 over 189. Okay, it's 1 over 189. Okay, perfect. Now let's then proceed to number B. So B says, question B says, the probability that a password chosen at random has exactly 1 B. It has exactly 1 B. The only condition they're giving us is that of a B. Okay, it's that of a B. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So a B could be here, a B could be here, and a B could be here. Meaning a B could be on the first place, on the second place, or the third place. There is nothing that they said regarding, let me see, regarding the digits. So it's still going to be 999, 999, 999. And what they had said was these are repeating, right? They said these are repeating. So it'll be 1 and 21, 21, 21, 1, 21, or 21, 21, 1. So for me, I will say probability is, as you can see, I'm basically repeating this thing 3 times. So I'm going to say this is 3 times. You can write it like this, or you can open a bracket, it's fine. 3 times 1 times 21 times 21 times 9 times 9 times 9 all over 21 times 21 times 21 times 9 times 9 times 9. Okay? All right. So let's see what we are getting. 21 squared times 9. What are we getting? What are we getting here? Our probability is 1 over 7. Right? Now, the probability that a password chosen at random will have exactly 1B is 1 over 7. Remember, I have said I'm not going to write this 1 times 21 times 21 times 9 times 9 times 9 plus 21 times 1 times 21 times 9. I'm not going to be doing that. It's the same thing. I'm just going to multiply it by 3. If you have time, you can just multiply, add all these together. Okay, you can add all of them together. They will still give you the same answer. Okay, all right. Now, number C, the probability that a password chosen at random contains or has at least one 4. This is where I'm going to use complementary events. Let me say not containing a 4. Okay, not containing a 4. I think the mistake I've been making is to not write probability of 1. So not containing a 4 would be 1, 2, 3, 4, 5, 6. So the letters are repeating, right? The letters are repeating, right? And so are the digits, right? And so are the digits. So we have 21 letters, 21 letters, 21 letters. But if they don't contain number 4, remember it's number 4 now and 0. So they are no longer 9, but 8, 8, 8. Okay? So probability of, let me put it well, probability of at least 1 4, of at least 1 4 is equal to 1 minus probability of no 4. What is it? It's 1 minus 21 times 21 times 21 times 8 times 8 times 8 all over 21 times 21 times 21 times 9 times 9 times 9. Now, to those that are asking why I had said 8, the condition was that they do not contain 0. So digits obviously will be 0 to 9, and that will make it 10 digits. But if they don't include 0, they will now be 9. Okay? Now, this question C further says contain at least 1 4. Now, here I'm saying if you're not containing 4, that means now this code has one number less. From 9, it's now 8. Okay? So let's get the probability. 1 minus 21 cubed times 8 cubed all over 21 cubed multiplied by 9 cubed. What is our answer? Our answer is simply 217 over 729. Okay? 217 over 729. Okay? That is your answer. All right. Perfect. Oof. Okay, there's no other question. Let's go to question 10. Okay, now we are going to question 10. Okay, now we are going to question 10. Now, question 10, let me see. Okay, I need to write it here. Question 10, calculate the number, consider the letters of the word winning. The repeated letters are identical. Okay. Pay attention. Repeated letters are identical. If the letters are arranged in any order without a repetition. Oh, now this is interesting. They are arranged in any order without a repetition to form different words. What is the probability that the word will start with W and end with G? Okay? Okay. So we're looking at winning. So now our answer, number A, it'll be when you start with winning, winning has how many letters? 7. 1, 2, 3, 4, 5, 6, 7. And then end with a G. So what do you have? So what they basically are saying to us is that generally to arrange a letter, you have 7 factorial ways of arranging this letter according to this thing, because they're saying without repetition, right? So without repetition, it's okay. Now, what we are having now is we are going to say, I do see here that we have winning. So probability that you start with W and then end with G will be, okay, let's start, will be, when you look at this guy here, it's one, forget about them. Okay. So, I should be using okay, let me just continue with red. But for now, you have 5 in here, right? Because they are repeating, you have 5 letters. Of the 5, N is repeating 3 times, and I is repeating twice. So what is your answer? Let's see. 5 factorial over 3 factorial multiplied by 2 factorial. So this is 10. Okay, so here you have 10 over, this is 7 factorial, right? This is 7 factorial. I'm sorry, I'm using different colors. Let me just not make a mess here. So it'll be this one here. You can make it 10 widths over 7 factorials. Okay, or if you like, you can put this thing as it is all over this. Now what do you have? 10 factorials over 50, 40, right? Over 50, 10 factorial, 10 over 7 factorial, sorry. This is 1 over 504. Okay, this is 1 over 504. Okay, perfect. Now for number B, and it starts with N. If it starts with N, it's okay. It'll be 1, 2, 3, 4, 5, 6, 7. If it starts with N, it's okay. Let's see what happens when it starts with N. When it starts with N, you have 6 letters to choose from. Okay, but of the 6, winning is repeated twice, and then N N is repeated twice, and then I is also repeated twice. Right? I is also repeated twice. So what is this? 6 factorial over, I'm going to say, this is 180. Okay, this is 180. So probability that you're starting with N, yes, probability that you're starting with the letter N is what? Is, let's see, it's 180 over 7 factorial, which is 1 over 28, which is 1 over 28. Okay, so this is the probability that you're starting with N. Pay attention, guys. For this question, it is different to what we did earlier, because it says if the letters are arranged in any order without a repetition. Okay, in any order without a repetition to form different words. So this is it. Okay, this is it. Now, number 11. Number 11, let's look at these boys and girls. So, I'm going back to that color. 7 boys and 6 girls are to be seated randomly in a row. What is the probability that 2 girls sit next to each other? All right. So what is happening is this. If the 2 girls are to sit next to each other, remember, is it 2 girls? Okay. This is 7 boys and 6 girls. So together this makes it 13. Number 8, this makes 13. So if we're looking at 2 girls, there will be 2 girls. One of the girls could sit on the left, the other on the right, and vice versa. Now we consider them a unit. Initially we had 13 people, but then when we minus these 2 from the 13, we will be left with, I repeat, when we minus 13, when we minus 2 from this 13, we will be left with 11. However, we are not necessarily minusing. We will consider these girls to be a unit. So 11 plus that one will be 12. 11 plus that one will be 12. Okay? Happy? Perfect. Now the probability that two particular girls, blah blah, sit next to each other is 2 factorial times 12 factorial all over 13 factorial. What is it? Let's see. This will be 2 over 13. I don't have to use a calculator. This will be 2 over 13. All right. This will be 2 over 13. If you like, you can use your calculator. It will really give you 2 over 13. Okay. Perfect. Number B, or question B. The probability that all the girls sit next to each other. So we have a group of 7 boys and 6 girls. There are 6 girls. In other words, there are 6 factorial ways to sort the girls. So from 13, if we minus 6, we will be left with 7. However, we consider these girls to be a unit. So we add 1. 7 plus 1 will be 8. Therefore, probability that girls next to each other, probability that girls are next to each other will be 6 factorial multiplied by 8 factorial all over 13 factorial. For this, one has to use a calculator. 6 factorial multiplied by 8 factorial all over 13 factorial. What is it? Our answer is 2 over 429. So this is the probability that girls sit next to each other. Okay, so this is it, guys. Do we have a 12th question? Oh, no, we don't. Okay, so this is it, guys. It's the end of our lesson on grade 12 probability. So ours ends here, and this is the last topic of the year. So see you in varsity. So bye.